What are you looking at?
Wow. Houston, I think we have a problem.
Uh-oh. What do you mean?
That's no buenos.
No. Okay.
That's going to be a problem.
It's going to cost some money. So what's the diagnosis? Tell me what's happened.
So the issue is one of the outer strands of our 1x19 side stay has broken. This is not a good thing because obviously when you break a strand, or as we call it, we pop a strand, that means that the whole structure has been weakened. So we have to look at replacing it.
So we know it's broken, why don't we just fix this one?
Okay, yep, so this one is broken, and yes, I could replace this one wire all on its own and we could go sailing again. The issue is when we first got Paikea, I replaced all of the stays at the same time, because when I did a rigging inspection when we first got Paikea, the starboard side at the top, I found that there was 3 strands that were popped and broken. So when that happened, I instantly went and replaced all 3 stays at the same time. This means that our stays have all got the same mileage on them. They've all got the same lifespan on them, and they've all had the same exposure to the elements as each other. So that means that if this one stay here has failed, it means that the remaining 2 of my 3 are about to fail, because they're in the same level of wear and tear and age as this one that's failed.
Why has this stay failed within its lifespan? So it should still be okay by now, shouldn't it?
Yeah, well, let's define lifespan a little bit. Lifespan, as the insurance companies see it, with a 1x19 wire is no more than 10 years. This is a very arbitrary number and it's a really silly number, but I guess they had to come up with a number, so that's the number they put on it. In reality, the lifespan of a stay totally depends on the miles that you do.
Not the years.
Not the years. Because a boat could sit here for 10 years and never leave the marina, and there's plenty of boats around here that are like that. Or you could have a boat like ours and some friends of ours where in 1 year we will do more miles than what an average boat will do in 10 years. Now this is the big driving factor, because that's what puts the cycle loading through the stay, and it is also the load that the stay sees that drives the wear and tear on the stay.
So that you're telling me that actually it didn't fail outside its parameters then?
Yeah, so it failed potentially outside of its age limit, because if you look at it as a 10-year, it failed. This failed potentially 2 years ago when we arrived here, when we first saw it, but we've been sitting in the marina with it popped while we do all the rest. So yeah, it's well and truly, if we say, look, this happened at year 6. So that's well and truly inside that 10-year span. So there's one of 2 things happening. One, we've seen what I call an event where it's been overloaded and it's popped the strand. Or 2, we've actually aged out the stay by sailing a lot of miles and a lot of good solid miles. So working the stay pretty hard. So what is the actual mechanical failure that we've sustained? So one of the issues with metal stays going into terminal swages is we end up with water and minerals like salt from the sea, dust and dirt from the atmosphere, pollutants from the air, all wash down into this area here. And this starts corrosion. So this adds to our mechanical failure, because it mechanically eats away at our wire. So our wires slowly get a little bit smaller. that then reduces the capacity for our wire to carry load.
And also plastic covers and stuff like that can induce corrosion.
Correct.
So depending on...
Yeah, exactly.
Yeah.
We see a lot of boats that have a plastic cover over the stay, over
Hold
the
the moisture
turnbuckles.
in. Yeah.
Locks the moisture and the dirt and everything, and it turns it into a real nasty zone of, and it hides it as well.
Yeah, so you can't check. What about accidents?
Okay, yeah, so another mechanical issue are accidents, like you happen to bump into something or something bumps into you.
Bad jibe. Maybe.
A bad jibe and a boom hits the stays and overloads the stay, or even just a bad jibe. If you're running flat off square downwind and it's blowing 30 knots and you have too much main up and you do a big jibe, that's a massive shock load into the stays.
And that can cause a mechanical failure.
And that will cause an overloading mechanical failure.
Okay. Well, yeah, because then that was my other question, was what just about overloading.
Yes. Okay. Overloading. This is a big subject, and I harp on it about it heaps with the weight of your boat. Overloading is directly related to the weight of the boat. Okay, because the more weight you put in your boat, particularly a multi-hull. So if we look at trimarans and catamarans, the more weight you put in it, the higher the righting moment is, the more stable it is.
Yeah, we've got a whole video on that.
That's a massive problem. And when we do that, that then gets directly related into the stays and the rig.
Yeah.
Okay, but the real catch-22 is because your boat's overweight, it feels safer because it doesn't want to lean over. So it feels safer, but what is actually happening is it actually gets a bit more dangerous in that you have a higher chance of breaking the stays in the rig.
And this is particularly true on multi-hulls. I think this is what we're
100%,
referring to, because on a yacht you just lean over.
Yeah, when you overload a yacht, yes, it also increases the load on the stays, but nothing like it does on a multi-hull.
What are we going to do? Are we going to do like for like?
So yeah, this is a big decision you've got to make when you're at this stage like we are. Do I just replace my wire stay with another wire stay? 9 times out of 10, I would say definitely. If you don't want to upgrade due to performance reasons, absolutely, just go like for like. If your boat is well known, well sorted and well engineered, then absolutely do a like for like swap. If you want to improve your boat a little, reduce the weight aloft, which is always a good thing, then you need to look at going to synthetic stays. If you're on a boat that's custom designed and custom built, you definitely want to have a quick little check to make sure, particularly if it's an older boat like ours, that the engineering on the original stay that's there is actually the correct specification. Just always have a quick little check as to what's there and what should be there.
The world of rigging has so many options. You've got carbon, Kevlar, PBO, Dyneema. What are we going to do?
So the answer is yes, there are a lot of options to choose from, and we are not going to go like for like. So we are going to change our metallic stays for synthetic ones, and we're actually going to change our synthetic PBO ones for a matching set of what's going to be used on the side stays. Okay, we're also going to change our forestay, and that's another subject on its own, and we'll get to that. So the options we have in synthetic world are PBO, like what our lowers are, Kevlar, which is very common, and then we have Dyneema. Now with the Dyneema options, that's split into 3 or 4 different categories, and I'll cover a couple of them. One is the material types. So we have SK99, SK78 and DM20. These are all different types of Dyneemas with very different characteristics. Then there is the subject of, we look at a braided rope style stay, or we look at a continuous loop uni cable. Now One of the advantages and disadvantages of, say, a uni-loop cable versus a braided rope style stay. I'll start with the braided rope style stay. Now this is what you'll generally see most of the cruising guys DIYing and putting on YouTube. Now it does work, but it's pretty low tech and it has a lot of disadvantages, but it has one very good advantage. Let's start with the advantages of the rope style woven Dyneema stay. The biggest advantage of it is you can DIY it and you can keep some spare stuff on your boat on a roll or wrapped up in a locker somewhere.
That does sound rather appealing.
And it is very appealing. And if you are doing some remote stuff and you get into trouble, like you have an accident, you can splice yourself a new stay, put it on and get yourself out of trouble. And to carry that spare stay on board, one, it's lightweight, and two, it's very compact to carry around. So that's the advantage of going with a rope style stay. Now, the big disadvantages with the braided material that people don't take into account, and it is a big factor because it affects the performance of the boat over the lifespan of the stay, not just the one-off occasion that it might have to be replaced, is the fact that you compromise on your stretch and your creep characteristics. Okay, when you've got a braided rope, that means all the fibers are sort of crisscrossing over each other. This introduces creep and stretch. It introduces initial creep, so when you splice it, and even though these lines are heat set and pre-stretched from the factory, when they're put into the real world situation and under load, they still need to do the initial settling creep or movement, right? So the stay where you initially set it up will move and get longer. Then over life, it will suffer the same issue as the uni style ones, where the creep comes back into the actual plastic material of itself. And that's when the DM20 versus SK78 versus SK99 equation comes into the whole thing. The other issue with the braided is the stretch. Now this is something that's inherently built into a braided rope. It means that the actual fibers are not in the direct line of the load path. Because they're woven, that means they're at an angle off of the actual loaded axis. And every time it's loaded, those fibers try to align with the load. And then when the load's reduced, they'll flex back to their original resting place. So this accounts for stretch as well as the actual plastic material itself stretching. So the braided cable's performance is always going to be lower and subpar to a uni-wound continuous loop cable. And this is why we'll actually be looking at going towards the continuous filament uni loop cable. Okay, so let's talk about material differences. So I talked a little bit about the structural differences of a braided versus a uni loop cable, okay? Let's talk about materials. So we can get the cables in all of those materials. Here I've got a continuous loop, unidirectional PBO cable as my lowers. Now this is the absolute worst cable I could have put on the boat for a catamaran lowers. And the reason for that is because of the shock loading and the on-off loading that's associated with multi-hull. Particularly on the leeward side, the stays tend to go slack and bounce around and the loads go on and off. When it's in the situation of a yacht, it's slightly different, where the rig tension in a yacht, your leeward shrouds should always maintain the tiniest little bit of preload. If your leeward shrouds are going slack, your rig is incorrectly tuned. So there's PBO, then there's Kevlar. Kevlar is the second, or probably the most common stay material in continuous filament cable world. Like PBO and Kevlar have two massive downsides, and that is they are not UV stable. And in particular, PBO is not moisture stable. So it's a great material to have in the marine environment, right?
It's not perfect for sailing.
Right. So when they make these cables, they've got to put all of these protective layers over them to make sure that the core material, the PBO or the Kevlar, is super safe from UV and moisture. So that's lots of wrapping and braiding to make sure that they're super secure. The lifespan on Kevlar, unfortunately, while it's cheap, it's quite short.
And then carbon?
Then carbon. Carbon is the gold standard because it is, basically it's the same material as your mast. It will last as long as your mast. The issue is that it will potentially fail due to intersections at the fittings or damages. But if you have a solid rod style carbon rigging, that's the gold standard. It's the lightest, stiffest, most aerodynamic option you can go, hands down. But it is also the most expensive.
I know you said carbon is the gold standard, but we've got to be realistic on what we can afford though.
Even in the world where we play with, 10 million plus euro boats, carbon stays are always they're bloody expensive.
Yeah.
You got to look at and consider things like the lifespan. It's expensive, but if you are owning the yacht for more than 10 years, then it is actually a no-brainer to go with carbon stays. You'll end up in front every time. So for us plebs, we have to look at the more cost-effective options and the availability. Yeah.
And transport.
So these are really big subjects. These materials aren't available to everyone everywhere in the world. So to get cables, if you're in a remote island in Fiji and you've just built your boat and you want to go and put new stays on, to get a nice PBO stay or a Dyneema stay that's a continuous wound cable, could be quite difficult because you've still got to ship that cable to you. Yes, they can be coiled into a reasonable size circle. They still got to ship a big package to you. Availability and the cost drive what gets used on your boat as much as what the actual best performing stay is to put on there.
So to start with, I was asking you whether we just go with, okay, we've sailed a heap on those wires, maybe we just came to the end of their lifetime earlier because of the miles that we're done. Why don't we just replace the like for like, right? I know we can't just replace one, we have to replace all of them. But why don't we just replace it all with wire? And you did a bit of a deep dive, didn't you? So I guess let's start there.
Me? Do a deep dive? Never.
Yes.
Yeah. Okay. I ended up looking much further into Paikea stays than I originally planned to. I knew I wasn't going to do a like for like because I wanted to save weight. So there were 3 parameters for me to look at with regards to the stays. That was 1, weight, 2, strength, and 3, stiffness. Okay, they're 3 driving factors for what you want to get out of stays, and in particular they're driving factors if you want to change from a like for like. You want to improve on at least one of those 3 if you're doing a like for like, otherwise you're going backwards, right? Initially I spec'd everything around this Paikea stays with the assumption that Paikea stays were engineered correctly from the get-go. Now, it's a big assumption, and you never make assumptions, otherwise you end up an ass. originally I made the assumption that the 12mm wire 1x19 316 was more than good enough. And why would I say it's more than good enough? Because this boat sailed halfway around the planet with the previous owner. The owners before him did several transatlantics with the boat, and we've done two transatlantics ourselves with the boat. So why would I assume any different, that the stays aren't good enough? Well, you make assumptions and you don't know, unless you have load cells on there, exactly where you are with your stay loadings and how close to the limits you actually are. So I actually got my first round of quotes based on doing replace my 12mm 1x19 316 stainless steel wires with a synthetic alternative, right? When those quotes came back, I was looking at them, and one of the things that sort of stuck out was the working load, saying that it was 3 tons, which sort of worked out in my head roughly somewhere. It should be somewhere around there, somewhere between 3 and 4. I thought, I might just double check this and make sure that my working load is that. To look at what the working load is, first I need to know the most important and most critical part of the whole puzzle, and that's writing moment. And writing moment, as I've harped on for so long, is about weight and the beam of the two hulls. Now, the beam of the two hulls has never ever changed, but the weight has, and it has drastically. And there was this little thing in the back of my mind was, we're taking a heap of weight out of Paikea. That's cool. Can I sneak down a wire size, or do I just stay with the higher safety factor? So I went and looked at what the writing moment was for Paikea. I sort of knew what it was previously because I'd looked at the writing moment when I checked the EA calcs for the mast, when we swapped the mast from the aluminium mast to the carbon mast. But then I went and looked at the stays and what sort of loads went into the stays, and I was a little bit surprised that the stay loading is much higher than I originally thought. Now, one of two things have happened here. Either A, my criteria for the rig design is much higher than what was originally planned for the boat, which is quite possible. Or two, the boat never really actually got any proper engineering calcs, and they basically took the rig that was for the 40-foot Katana at the time and then just plonked it straight on top of the 42-foot Katana and went, it's only 2 feet longer or 600mm longer. That's not going to change the writing moment. And technically it doesn't, because it doesn't change the width of the hulls, but it does change the weight. Now, you'd think that only adding a little bit on the back or the front or whatever they did wouldn't change the weight, but it changed the weight, I think, quite substantially, in that the boat got a lot more volume in it because they put a different deck on it. With the 42, they were able to get a nicer, bigger, more voluminous deck on it, which meant they could put more stuff inside. So from the original design, I believe the weight got quite a bit higher. So when we were in Valencia, we weighed the boat, and the crane told us that we were about 8.8 tons when we came out, which was a bit of a shock that we were that heavy. And of course, since we weighed that, was 4 years ago, before we went to the Caribbean, since then we've pulled a bunch of weight out. So we were sailing lighter when we were in the Caribbean, and we're sailing, obviously, or going to be sailing much lighter now. So my aim was that we actually try to get it down to this theoretical weight that was being bantered around at the boat being 7 ton. So I based my load calcs on the beam of the boat. Now, that's the beam of the centerline of the hulls, not the overall beam of the boat. Okay, that was a fixed number. But what is a variable is my weight. So I looked at several weights I looked at 8.5 tons down to 7 tons and how that affected the writing moment. And you'll be able to see that. I've got a nice pretty graph here. Now, the graph shows writing moment as our red dotted line down the bottom here, and that's in kilos per meter. So when the boat was 8.5 tons, we had a writing moment that was approximately 27,000 kilos. That's 27 tons per meter. So that's the equivalent. If I had a stick 1 meter long and I put 27 tons on the end of it, that's how much force the boat applies or is able to resist to capsizing it. So that's really high. That's up there with 70-foot monohulls. If I take Paikea's weight down to 7 tons, so I've reduced the weight. This is all this work that we're trying to get the boat down to. And this is down to the weight that the yard originally said the boat was. Down at 7 tons.
That's what this whole removing furniture, replacing it all with composites, what we've been doing over the last year. This is all why we're doing it.
Why we're targeting this 7-ton mark. 7 ton is, for us, a moderate weight to be working with. It's still heavy. You know, we come from racing backgrounds. For us, a 42-foot cat should be under 3 ton. But this is not a race boat. So if we look at Paikea down at 7 tons, our righting moment is about 21 tons per meter. Okay?
Seems like still a lot.
It is still a butt ton of righting moment, but it's 6 tons per meter less. And that's a substantial number. It's not insignificant, right? And if you look at our boat and how big those numbers are, if you're on a Fountain Pajot or a Lagoon or even a newer Katana where they're much heavier than us, just think what the righting moment is of your boat. It's going to be massive. Right. So if we look here, we can see a yellow line. Now this yellow line is the very important one. This is our cap shroud or our main side stay load on the boat. Now with Paikea, when we put the carbon mast on, we changed the staying arrangement so we had a set of lowers on there as well. Now the lowers actually take a little bit of stay load with them as well. So it actually reduced the stay load because some of it's being shared on the lowers. Right, so you can see that here with the green line. Okay, so you can see on our graph over this here, working load in kilos. So when we're down at 7 tons, our lowers are taking just over 2.5 tons of load in the lowers. In the cap shroud, we're looking at just under 5 tons of working load in our cap shroud. Now, I need to also explain when I was saying I may have changed the parameters a little bit from the design brief originally. I don't think I did because back in the day, the design briefs were, the maximum working loads were calculated around your maximum riding moment. Now that's the moment where you just fly a hull. That's your maximum righting moment. And that's what I have designed these to, so that Paikea can safely fly a hull if she's at 7 ton. Okay, that's what all of this is designed around. So you can see here that we've got the lowers at this load, the cap shrouds at this load. But if we look at Paikea's weight when she's 8.5 tons, you can see that the lowers were working at just over 3 tons through the lower stay, and we were just under 6 tons with the side stays. Okay, so it's a substantial jump in load in what the stay has to take.
Just for 1,500 kilos.
Yeah, exactly. Now, if we look up here, I've also put in 3 different brands of stainless steel wire. Okay, Paikea, we believe, has the Blue Wave
1x19.
1x19 from Denmark. It has the Blue Wave turnbuckles. The rigging shop that we got everything from was selling Blue Wave material. So as far as I know, it's Blue Wave 1x19 stainless steel wire. You can also see that the Arcus wire, which comes out of Australia, I'm 99.999% sure. It comes out of Australia. Whether it's made in Australia is completely debatable. And then there's, I took another one as a left field. Jimmy Green sells online, lots of stuff. They also sell 1x19 wire, and they sell the KOS Chinese, and very proudly Chinese 1x19 wire. Nothing wrong with it. It's good. It's stainless. It's good Chinese wire, but you can see here that the load capability of the three is quite different, because stainless steel, all being 316, has a range in which you can make the material fit inside the 316 category, and there's top of the range and bottom of the range. And you can see very clearly the three different brands, and they go from top of the range, middle of the range, bottom of the range. So if you had an Arcus 1x19, it has a braking load of 12 tons, or just over 12 tons. The Blue Wave stuff that we've got is 11.2 tons from memory, and the Chinese stuff from Jimmy Green is approximately 10.4 tons, right? So you can see there's a difference. Now, if we apply a safety factor to that, and we apply a safety factor of 2 to 1, now this safety factor thing is a big subject. If we apply a safety factor of 2 to 1, which is full-blown race boat safety factor, we can see here that our yellow line load sits below the Australian-made Arcus wire if the boat was 8.5 ton, and it comfortably sits under it if the boat is 7 ton. So if we have the Blue Wave wire,
Yeah.
and Paikea weighs 8.5 ton,
Yeah.
that's
why we're breaking
the braking load with a 2 to 1 safety factor. We're above the safety factor, so we're at, I think it was 1.8 to 1 safety factor, and not a full 2 to 1. So that's super skinny.
Yeah, and that would potentially explain why the wires are breaking.
Yeah, exactly. So now we'll talk about the safety factor thing. 2 to 1 is too skinny for a cruising boat.
Yeah,
right?
Exactly. That was going to be my other question.
Yeah.
It's like,
Okay.
doing 2 to 1 for safety factor.
2.5 to 3 to 1 for stainless steel wire is the safety factor you want to look at. Right, so let's have a look if we do that. Here's the same graph and everything, same loads. The only thing that changed was that I moved it from a 2 to 1 safety factor down to a 2.5 to 1 safety factor, which is still super skinny. Okay, there's not a lot of meat on the bone, not a lot of reserve. If we look at this load of our side stay, a yellow line of our cap shroud, it is above all of the wires, even at our 7 ton loading. It just crosses the good old Australian made one down here at the 7 ton. So you would say 2.5 to 1 safety factor with the Australian made one if the boat was at a sailing weight of 7 tons. Okay, so that was a big surprise at my end that our working loads were that high. One other little safety thing that I did was when we originally had the boat, we had the double diamond arrangement, so we only had a single side stay holding it up. If for some crazy reason I want to go back to that arrangement, where I put a carbon diamond on the thing because I get tired of the lowers and it's annoying and it doesn't suit us for some reason, I want to change the rig. I want to future-proof ourselves a little bit, but it's also if for some reason I want to tune the mast and I want to actually take load away from the lowers to allow the bottom panel of the or the mid panel of the mast to move, that transfers load into the side stay. I want to look at the side stay carrying the maximum load all by itself as a double safety in the bag, keeping everything, Okay, so I modeled that, and that is here. So this is now the new loads of Paikea with just the side stay only, not sharing the load with the lowers. You can see at the 8.5 ton Paikea, our shroud load is just under 7 tons. Okay, so there is no way we're gonna sit and these are our wires based at 2-to-1 safety factors. You can see we're way above that. We have to have Paikea below 7 tons to have any of these wires work. Okay, so super important to understand the materials for your stays and what loads they need to work at. And more importantly, you need understanding the loads that the stays work at and how they're affected by putting weight in your boat.
So that means that your choice was to go up in size for your wires,
Yes.
or, which doesn't address the forestay issue, which you went into detail with earlier.
Yes.
So the only other avenue really is
Synthetic. Yeah.
synthetic. And we can't afford the carbon. Don't want to go a roll of Dyneema for all the reasons that you've already said.
Yeah.
And we can't do PBO or Kevlar because they don't like the ocean.
We can do Kevlar, but I don't like the lifespan of Kevlar. So it narrows things down pretty quickly.
Yeah. So then there's a couple of companies here in Europe that could look after us, and we went with Fabrica.
Yep. So
which is a smaller company.
Yep.
Which is nicer than we did look at Future Fibers, but they're quite a big company, whereas these Fabrica guys were a little bit more...
Were able to be more reactive to us.
Yeah, they were really good at having chat and talking about what we needed in particular.
Yeah.
Obviously we got a very different rig.
Yeah. It also helped that I have worked with them in the past on previous projects. So there was a small working relationship there. So to work with them further was really nice.
Yeah. And what they're going to make us will be stiffer.
Yep. Okay.
It will be
much stronger,
and it should last a long time.
It will be a butt-ton lighter.
And it'll be lighter.
And it's the lightest option we can get.
And they're happy to work with you and give you exactly what you want.
Yeah. I will show you the quote that I received from Fabrica, because one of the cool things with Fabrica's quotes is they give you predicted braking loads, they give you predicted stretch rates, and then once they make your stay, they actually do the QA component, and they will then, when they send you the final stay and invoice and everything, there is a performance comparison between what was quoted and what was actually built and what is actually going on your boat. And that's super cool. For me, in the professional sense, when I was fitting their stays on clients' boats, that I had predicted numbers, so I could sort of look and see, and if there were anomalies, I could rule out that it was the stay, or I could say, oh, the stay is a bit stretchy. Why is it a bit stretchy? So I already could understand the stay before I fitted it to the boat. So that's super cool. Okay, so let's look at what comes through on the quote from Fabrica. Here they actually put at the top what I sent through in my request. So I gave the lengths, the minimum, the working loads, the minimum EAs, the lengths, the turnbuckle deductions, and the type of interfaces between turnbuckles and mast and loops and things like that. So they knew what they were designing their stay around. Then they came back with the stay with dimensions of the fittings at each end, at the bottom and at the top. And then down here is the really cool part. This is the exciting part. So it came back with an EA. Now that's the stiffness of the stay. That's how much it will resist stretching. So how stiff it is in relation to not being able to stretch. Then they have a max working load. Okay, so the max working load is 6 ton, which is what I specifically requested. You could see from all the charts that I had before that with the lowers, I was below 6 ton, but without them, I was above 6 ton. Then you have the NBL, the net braking load, or in this case, the minimum braking load is 24 tons. So we've moved from our other stays, which had braking loads of 12 tons, now to a stay that has a braking load of 24 tons. So that's a massive step up. Now these guys work on a safety factor of 4-to-1 with the synthetic stays for a whole bunch of reasons that we'll ask and talk about when we get to Fabrica as to why that is. Okay, so the diameter is the only downside to this particular stay. We have grown from 12 mil up to nearly 19 mil, nearly double the diameter. Now that's not great, but it's a sacrifice I'm willing to make. Because if you look at the weight is only 3.4 kilos per stay, which is significantly lighter than the stainless steel one. And we'll put the weight of the stainless steel one in here because I haven't got it right there on my computer to do the comparison for you, but it's significantly lighter. So yes, but I've also, DM20 is the softest material that we have available to us to make the stays from, but it has some really good characteristics. It's the lightest material we can make the stays from. It's the stay with the least amount of creep in the Dyneema family group. It's up there with the Kevlars as far as creep's concerned. It is potentially the longest lifespan one. Now this is something that hasn't been fully developed yet in the industry because it's still relatively new. If you compare it to SK99 and SK78, SK99s and SK78s are a part of the SK series of Dyneema that's been work hardened, okay? That's how they get the extra strength out of it. So Dyneema is an amazing material that it actually gets stronger the more you use it. So it work hardens. Now when you get to the SK99 end of it, our theory is that you're actually getting closer to the end of the life of the material because you've already work hardened the bajingas out of it to get it to that strength and that cycle of its life. Whereas the DM20 is still essentially the virgin material that hasn't been work hardened a whole heap. So it's still got a whole bunch of life left in front of it to work harden and get stronger and stiffer and all the rest of it. Now that's just a theory at a few of us that sort of look at this stuff, but that has to be proven over time. So that's why I went with DM20 versus SK78 or SK99. Now also it should be noted that SK78 actually has better creep properties than SK99, even though SK99 is a higher braking strength material than SK78. You got to look at it as a fit for purpose material more than just going, I'm going to get the highest braking load material there is on the market. Okay, so if you get SK99, yes, it has a higher brake load, but it has a much higher creep rate. So you're always, over a couple of years, going to be constantly stretching your stays and tightening them up. So the next bit will be us going and visiting the factory. There was a lot to cover here, and there is so much we've not covered because it is a big subject.
Yeah, well, maybe we might put the extra bits on our members' site. So if you wanted to do a bit of a deep dive, we'll put some stuff up there.
Yeah, so hopefully you've learnt something, because we certainly did. And it'll be a little bit exciting to go and have a look at the factory where they make these things. And then the halyard comes from the head sail through the actual torsion fitting up here, and then goes back down the luff of the sail. So it takes away the lock out of the swivel that we're looking at. It'll be a lot lighter and simpler.